All right, so today we're going to keep moving on exponential equations. We're going to take a look at what happens when we have something in the denominator and how that changes our process, and just kind of refresh real quick how we handle exponential equations. So let's start with our do now today. Why don't you make sure you have your power sheet handy and hit pause and see what you can do with 9 and 27. Think about what your bases are. Okay, let's see how you did. So the first thing that I want to remember is that 9 squared, if I take a look at my powers, 9 squared is 81, which is already bigger than 27. So I know I have to go down. So 9, remember, if I take a look at that base, 9, well, 9 goes to a 3. So I can see that right here. So then if I go over here and look at the 3's, I see I have 27 is also a base of 3. So let's go ahead and rewrite that. So 27 is 3 cubed, and the 9 is 3 squared. Okay, who remembers what we do from here? Yeah, the bases are the same, so those are going to cancel out. And I'm left with the powers. So I have 2 parentheses 3x plus 6 is equal to 3. I'm going to distribute 6x plus 12 equals 3. Subtract my 12. 6x equals negative 9. Divide by my 6, and x is going to equal negative 3 over 2, because that is going to simplify. All right, so let's take a look at our new piece today, and it's really not significantly different, but they're negative. They're negative. So what do you remember about negative powers? Yeah, negative powers, if I give you x to the negative 3, that's actually 1 over x to the third. So negative powers means things are in the bottom, or are reciprocal. They're in the denominator, okay? So when I am trying to write something as a rational exponent, I have to rewrite them without negative powers, just like I know I have to rewrite this without negative powers. So a to the negative 1/3 would be 1 over the cube root of a. And a to the negative 1/2 would be 1 over the square root of a. And this one, I know I would have the a here, the 5 is the index, and there's a 4, but I know it's on the denominator. Okay, so everything has to move to the denominator. So here's kind of our rule to kind of refresh that. Negative powers mean reciprocal. Because if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. So rational exponents are the same thing. They still have to continue to apply that negative power rule. So here's what happens at this point, okay? So I see that I have 4 to the x plus 1 and 1 over 64. And I have 6, 8 minus x, and 1 over 216. So I have a fraction, okay? I have a fraction. So I know that means that I am going to have to be dealing with negative powers, okay? I have to deal with negative powers because the bases have to be on the same levels. They both have to be in the numerator to be able to solve this, okay? So if I take a look at base 4, I see over here 4 cubed is 64. 4 cubed is 64. So I know that this is 4 cubed. So 4x plus 1, and that is 1 over 4 cubed. Well, it can't stay there. It can't be on the bottom. I have to move it to the top. So how do I move something? Yeah, it has to be the opposite. So the opposite would be 4 to the x plus 1 is equal to 4 to the negative 3. So this becomes negative, okay? Negative. So it has to change the sign to move it to the top. So now I have like bases. My 4's can go away. At x plus 1 equals negative 3, I'm going to subtract my 1. X is equal to negative 4. All right, let's try the 216. So I see over here was 6 cubed. There's a 216. Okay, there's a 216. So if I rewrite this, 6, 8 minus x, and 1 over 6 cubed, remember that has to switch. So 6, 8 minus x, and 6 to the negative 3. 6 to the negative 3 because it cannot stay on the denominator. Okay, so how do we solve it from there? Well, my equation is 8 minus x equals negative 3. I'm going to subtract my 8. I have negative x equals negative 11. Remember, that is a negative 1, so x is going to be positive 11 because I needed to divide by the negative 1. Negative 1. Okay, let's try a couple of just regular ones. See if you can do these. Remember, these are probably going to go down. Okay, you might have to change both sides. So go ahead and hit pause and see what you can do with these. Okay, so we've probably kind of come up with a consistent, we've been seeing the 9 and 27 showing up a lot. And we know 9 is a base of 3 and 27 is a base of 3. So I know that 9 becomes 3 squared. And I know that 27 becomes 3 cubed. So again, my base is the same, so I get to pull out my powers. So 3 times 4x and 2 parentheses x plus 1. So let's go ahead and solve this. 3 times 4 is 12x. 2 times 1 is 2x plus 2. Okay, remember, x's have to go to one side, so I'm going to go ahead and subtract my 2x. And I have 10x equals 2, dividing by 10. X equals 2 over 5. Sorry, take that back, 2 over 10. Which is 1 over 5. Remember, we have to simplify those. Now, 25. We know 25 is a base of 5. And I also see over here that I have 125 as a base of 5 right there. So I know I have to go down, okay? Have to go down. So 125 is 5 cubed. My 3x is still there. 25 is 5 squared. 2x minus 1. Bases are the same. Pull out my equation. And solve. 2 times 2 is 4. 2 times negative 1 is 2. 3 times 3 is 9. Again, move your x's to one side. So I'm going to go ahead and move my x's to the other side. Since there's only one number, 9 minus 4 is 5. Divide by 5. X is going to equal negative 2 over 5. All right, so see what you can do with these today. Remember, negative powers, if you see something in the denominator, you need to flip it and make it negative so it moves the top, and they have to be on the same level to be able to solve. So make sure you throw that negative in there. And yeah, we're going to move on tomorrow. So reach out to us if you're stuck.